Hi, I'm Julia Claxton. I'm on the science team here at Glee, and I'm going to talk about why we use the thermopile. So, to get started, we're going to talk about how the thermopile works. And basically, it detects infrared radiation and converts that to a temperature. This is advantageous because we don't actually have to touch the thing to measure it, which touching it will add or remove heat sometimes, and that could just alter our reading a little bit. So, you might be wondering, what is the difference between this kind of temperature sensor and our actual temperature sensor we covered a couple modules ago? Well, our traditional temperature sensor, like we just mentioned, it has a physical probe, and so it has to touch the thing that it's reading to get a reading, and that adds and removes heat, and that's not great because we want like accurate data. So that'll interfere with our measurements. So we are just going to use our thermopile to take readings of, for example, the regolith, and that uses non-contact means, so using infrared radiation, and that just avoids the issue entirely because we don't actually have to touch anything to measure its temperature. So this actually, it just measures it directly, and it doesn't get interference from the temperature of the lunosat or like being in sunlight the way that the temperature sensor would. This also allows us to like determine the thermal properties of the regolith, so emissivity or thermal conductivity, etc. So generally, the temperature sensor is a diagnostic sensor that tells you what the lunasat's temperature is, but thermopile tells you what other things' temperatures are. For example, a science case here, we could do ground truthing. So the Lunar Reconnaissance Orbiter, LRO, has created like a global temperature map of the lunar surface, but this is a very low resolution map because it was done from orbit. So what we can do is focus in on a specific area and take a bunch of readings with our thermopiles and kind of verify and refine that data from LRO. So basically, this has the same uses as our temperature sensor for local and distributed cases. However, it does perform a little better because it doesn't need to touch the regolith to actually measure its temperature. And that just makes it a little more reliable as far as measurements go. So in a local case, we can see the temperature curve at a specific location over the course of a full lunar day. And in our distributed network, we can just get a map of the temperature over the full day, but also over a broad region. So in summary, the thermopile measures temperature without being in contact with what it's measuring. So that's great. It doesn't alter the reading with its own temperature. And this lets us measure regolith and thermal properties just a little bit better. And we can use this, for example, for ground truthing, remote measurements, measurements of the temperature curve over a day, and all kinds of other science cases.